Hello students. So today I'm going to teach you how to factor the sum and difference of two cubes. Okay, let's start with the difference of two cubes. So the pattern or the rule for the difference of two cubes is a cube minus b cube is equal to the quantity of a minus b times the quantity of a squared plus ab plus b squared. So there are conditions for a binomial to be a difference of two cubes. The first one is the two terms must be both perfect cubes. Number 2, minus must be the sign between the two terms. And 3, the exponent of the variables must be multiples of 3. So here are the different perfect cubes. When we say perfect cubes, this is the answer when you multiply one number by itself 3 times. So for example, we have here 1 cube. This means 1 times 1 times 1 is equal to 1. Another example is 2 cube, which means 2 times 2 times 2 is equals to 8. And so on. So for 3 cube, we have 27, 4 cube, 64, 5 cube, 125, 6 cube, 216, 7 cube, 343, 8 cube, 512, 9 cube, 729, and for 10 cube, we have 1000. Now, let's have an example. So, we have here example number 1, factor y cube minus 27. Let's first check if the given binomial is a difference of two cubes. 27 is a perfect cube, that is check. The exponent of the variable y is a multiple of 3. And the sign between the two terms is minus. So we can factor this as a difference of two cubes. Now let's copy the given. In factoring difference of two cubes, we have two different kinds of factors. We have the binomial factor and the trinomial factor. In getting the binomial factor, we're going to get the cube root of the first term and the second term of the given binomial. In exponent, we're going to divide the exponent by 3. We have here y cubed. Now divide 3 by 3. The answer is 1. We're now going to write only y. If the sign is minus, the sign of the binomial factor is also minus. Then get the cube root of 27. The cube root of 27, or the number that when you multiply by itself 3 times, is 27. The answer is 3. That means 3 times 3, 9 times 3. The answer is 27. Now, to get the trinomial factor, we're now going to look at the binomial factor. First, square the first term of the binomial factor, which is y. We're now going to write y squared. Then, the opposite of the sign of the binomial factor, minus, the opposite is positive. To get the middle term, you're going to multiply the binomial terms or the terms in the binomial factor. Y times 3, the answer is 3y. Always remember that the last term in the trinomial factor is always positive. And then square the last term of the binomial factor, which is 3. That is 3 squared. The answer is 9. The factor of y cubed minus 27 is the quantity of y minus 3 times the quantity of y squared plus 3y plus 9. Next, example 2, factor 8x cubed minus 64. Again, before answering or before factoring, check if the given is a difference of two cubes. 8 and 64 are perfect cubes. The exponent 3 is multiple of 3. The sign between the two terms is minus. meaning this is a difference of 2 cubes. Now, let's factor 8x cubed minus 64. Make two parentheses, one small and one big. Get the cube root of 8x cubed. What number, when you multiply by itself 3 times, the answer is 8. The answer is 2. Then divide the exponent 3 by 3. The answer is 1. So we're now going to write only 1x. Next is the minus sign. And then the cube root of 64, which is 4. Meaning 4 times 4 times 4, the answer is 64. Next, let's get the trinomial factor. Square the first term of the binomial factor, that is 2x times 2x, or 2x squared. The answer is 4x squared. Then the opposite of sign of minus is plus. Then multiply 2x and 4, that is 2x times 4. The answer is 8x for the middle term of trinomial factor. And last, always positive sign. Square of the last term of the binomial factor, which is 4. 4 squared is 16. The answer for 8x cubed minus 64 is the quantity of 2x minus 4 times the quantity of 4x squared plus 8x plus 16. Next, example 3. Factor 27m to the 4th power minus 8mn to the 6th power. Again, check if the given can be factored by difference of two squares. Or rather, difference of two cubes. 27 and 8 are perfect cubes, right? But if we look at the exponent, which is 4, and the exponent of m here, which is 1, this is not a multiple of 3. So let's see if they have a common factor. Looking at the given, 27m to the 4th power minus 8mn to the 6th power, they have a common factor, which is m. Now, divide 27m to the 4th power by m. The answer is 27m cubed. And then divide 8mn to the 6th power by m. The answer is 8n to the 6th power. Now, let's see if the other factor can be factored by the difference of two cubes. 27 and 8, again, they are both perfect cubes. The exponent 3 and 6 are multiples of 3, and the sign between the two terms is minus, meaning this is now a difference of two cubes. Now we can now factor it. Make two parentheses, one small and one big. Again, get the cube root of the two terms. So the cube root of 27m cubed is 3m minus the cube root of 8n to the 6th power is 2n squared. How do we get squared? Divide the exponent by 3. So 6 divided by 3, the answer is 2. Now get the trinomial factor. Square the first term of the binomial factor, 3m. That is 9m squared. The opposite of minus is plus. Multiply the two terms, 3m times 2n squared to get the middle term. The answer is 6mn squared. Then positive, square 2n squared. The answer is 4n to the 4th power. The factor of 27m to the 4th power minus 8mn to the 6th power is m times the quantity of 3m minus 2n squared times the quantity of 9m squared plus 6mn squared plus 4n to the 4th power. Now, let's move to the sum of two cubes. Same with DTC, or difference of two cubes, there are also conditions. Number 1, two terms must be both perfect cubes. plus must be the sign between the two terms, and the exponent of the variables must be multiples of 3. This time, if you're going to take a look at the sign, if the given is positive, the binomial factor is also positive, and the middle term of the trinomial factor is now negative. Let's have an example. Factor 1 plus 8k cube. Again, check first if the given is a sum of two cubes. 1 and 8 are both perfect cube. The exponent 3 is multiple of 3. The sign between the two terms is plus. Now, let's factor. Make two parentheses, one small and one big. Get the cube root of 1 and 8k cube. The cube root of 1 is 1 plus the cube root of 8 is 2 and 3 divided by 3, that is 1. So, we're now going to write only 1k. Then get the trinomial factor. Square the first term of the binomial factor, 1. 1 squared is 1. The opposite of plus is minus. Multiply the first term and the second term of the binomial factor. 1 times 2k is 2k. Always positive for the last term. And then square 2k, which is the last term of the binomial factor. The answer is 4k squared. The factor of 1 plus 8k cube is the quantity of 1 plus 2k times the quantity of 1 minus 2k plus 4k squared. Now, let's have example 5. Factor 5h plus 40hk cube. Is 5h plus 40hk cube a sum of two cubes? Let's check. 5 and 40 are not both perfect cubes. They are not both perfect cubes. Meaning, from there, we cannot factor this as a sum of two cubes. But taking a look at the given 5h plus 40hk cube, they have a common factor, which is 5h. Now, let's get the other factor. 5h divided by 5h is 1 plus 40hk cube divided by 5h, the answer is 8k cube. 1 plus 8k cube, which is the other factor, can still be factorable. It is a sum of two cubes now. So, let's factor this. Get the binomial factor by getting the cube root of the first and the second term. Cube root of 1 is 1. The sign is plus. The cube root of 8k cube is 2k. Then, get the trinomial factor. Square the first term of the binomial factor, 1. 1 squared is 1. The opposite of plus is minus. Multiply 1 and 2k, that is 2k. Always plus. Then 2k squared, or 2k times 2k, we have 4k squared. The factor of 5h plus 40hk cube is 5h times the quantity of 1 plus 2k times the quantity of 1 minus 2k plus 4k squared. And that's it. Thank you for listening and for watching. Hope you understand.